Question 2. Function of fx equals x plus 2, x minus 1 squared. A, we need to sketch the graph of y fx and identify the coordinates. B, we need to sketch the graph of y equals f1 over x and identify the coordinates. C, sketch the graph of y equals f minus 2x and identify the coordinates. First, just to show that x plus 2, x minus 1 squared is written twice. Next is to set these factors to 0. Now I've set this to 0, so I get x equals minus 2, x minus 1 equal to 0. That implies x equals 1, x equals 1. These are factors and these are roots. I need the roots to be able to sketch the graph. If I expand x minus 1 times x minus 1, I get x squared minus 2x plus 1. Now I need to multiply this factor by these quadratic factors. I get x cubed minus 2x squared plus x plus 2x squared minus 4x plus 2. So that's multiplying x by x squared, x by minus 2x to get minus 2x squared, x by 1 to get x. 2 times x squared will give me 2x squared. 2 times minus 2x will give me minus 4x. 2 times 1 is 2. So if I simplify these, x cubed, that's x cubed, minus 2x squared plus 2x squared cancels out. And I'm left with x minus 4x, which is minus 3x plus 2. Y-intercept is plus 2. This is where it crosses the y-axis. So y-intercept is plus 2. I want to find the turning point of this graph. To find the turning point, it means I need to differentiate. I need to find the gradient. The curve where it's turning, the gradient is 0. And the gradient is 0 here. So the way to find it is to differentiate. The way to find it is to differentiate this curve. That means the y dx. So if y is a x to the power of n, the y dx equals a n x n minus 1 power. And to do that, we go from cubic to quadratic. So it will give us two solutions of x where the turning point will be. And that's how to use the formula. So I'm going to apply this formula. This is y here. Each 3 terms is going to be one of these. So I'm going to apply these to each term. So now I've applied the differentiation to this curve here. The y dx will be 3 times 1. There's 1 here. So that's 3. And then 3 minus 1 is 2. So I'm applying this formula to this one here. So n is 3. That's that. A is 1. So 3 times 1, 3. And then 3 minus 1, 2. 3 minus 1 is 2. For the second one here, there's a power of 1. 1 times minus 3 is minus 3. Then 1 minus 1 is 0. X to the power of 0 is 1. So 3 times, minus 3 times 1 is minus 3. 2 here has x to the power of 0 next to it. So if we bring the 0 down, 0 times 2 will be 0, and that disappears. So therefore, a constant will disappear when you differentiate it. Now I need to set that to 0. So that becomes 0, because that's the turning point. The gradient is 0 at the turning point. There's no slope. This is positive slope. This is negative, negative, positive slope. 0 slope, 0 slope. So 3 is a common factor here. So I've taken the 3 out. You get x squared minus 1 equal to 0. If I divide both sides by 3, I get. So I've divided both sides by 3. I get x squared minus 1 equal to 0. Then take 1 to the other side. So I get x squared equals 1. And if we square root both sides, I get x equals plus or minus 1. Or I could apply a difference of 2 squares here, and I get x minus 1, x plus 1. And therefore x equals 1, x equals minus 1. So that's the point here where x equals 1. So that's what that's saying. That point might be x equals minus 1. And here might be x equals 1. So when x is equal to 1, so that'll be 0. When x equals to minus 1, I'll get 1 here. And that's minus 2. Minus 2 squared is 4. 4 times 1 is 4. Now I found all the values I needed. I've got the roots on the x-axis, the solutions. I've got the turning point, the maximum and the minimum turning point. I've got the intercept on the y-axis where it crosses the y-axis. Now I can sketch the curve. Okay, so these are the roots, and the y-intercept, y equals 2. At the turning point, x equals minus 1, y equals 4, x equals 1, y equals 0. Those are the points, minus 2, and the intercept, when x is minus 1, y equals to 4. That's the turning point there. So I've got a turning point here. Because it's cubic, the graph is coming from the third quadrant. So there must be another turning point here. So coming down and then going up, and that is coming down here. Obviously it's coming from the third quadrant. This is the third quadrant, second, and the first quadrant. And that's the fourth quadrant. So at the point here, this is the equal roots and also the minimum. And the coordinate here is 1, 0. So that's the minimum and equal roots as well. This is the maximum. And the coordinate is minus 1, 4. And this is the other root, minus 2, 0. The intercept on the y-axis, 0, 2. And this is the curve that we just sketched. B, sketch the graph of y equals f of x over 2 and identify the coordinates. Right, so with f of x over 2, the coordinates, the roots will be x equals 2, because you are changing, if you're multiplying by the x rather than the f of x, you're changing the x. So if you're multiplying by a, if you multiply f of x and you're multiplying the x by a, you're going to have f of x over a. So if I have a to be a half, and then I get f of 1 over half, which would be 2x. So that's how I get that. Because if you're changing a and you multiply by a, you're multiplying the x by a, you're really dividing it by a. And if you divide by a, you're multiplying it by a. So that's what this is. So the y value wouldn't be changing. It's only the x value that will be changing. So what it looks like is, because we're multiplying a half by x, we're stretching the curve horizontally. Okay, so we've got the graphs ready. This is the y-axis where equation is x equals to 0. And that's the x-axis, equation is y equal to 0. Now I'm going to plug in those points here and then sketch the curve. So we have when x is 2, y is 0. So next, x is 2. That used to be 1, y is 0. When x is that 2 again, so that's equal roots. When x is minus 4, y is 0. And when x is minus 2, y is 4. Was minus 2. That's a turning point there. And so there are intercept when x is 0. When x is 0, y is 2. So it doesn't affect y. Right, again, so this will be the maximum turning point, and this is the minimum turning point. Also equal roots there. And this curve will be going to the 4 there, and this curve will be going to 2, and then meeting the maximum there, and that will be going all the way to infinity y. You can see the equal roots there and the minimum. So the value is 2, 0. And the maximum here, and the value is minus 2, 4. And we got root here, which is minus 4, 0. And the intercept here will be 0, 2. So we can see that the graph has stretched along the y-axis by a factor of 2. So the scale factor here is 2, stretched along the y-axis. So this is the fx. You can see the value of fx here. And this is fx over 2. So it's been multiplied by 2. You could be asked to write the equation of fx over 2, but fx is x plus 2, x minus 1 squared. F of x over 2, which is what this is, because as a half times x is x over 2, that will be equal to, so you just change wherever you see x, you replace it with x over 2. So that would be x over 2 plus 2 and x over 2 plus 1, x over 2 x over 2 minus 1 squared. So that's what you do, and then you multiply those factors out. You may be asked to write the equation of f of x over 2. Remember, f of x is x cubed minus 3x plus 2 when we expanded the f of x. That's what we get earlier. Now what we're going to do is replace all the x by x over 2 and x by x over 2. So I've replaced the x by x over 2, x over 2. So now that's the equation of f of x over 2, which is x cubed over 8 minus 3x over 2 plus 2. You can see that's x cubed. 2 cubed is 8. And that's how we got that. So now we can plot these points on the graph. You can see this is minus 2x, which means you're dividing it by minus 2. Each one will be divided by minus 2. Divide that by minus 2, you get that. Divide that by minus 2. Divide that by minus 2, you get that. And divide the x by minus 2. Divide that. So that's what happened when you're changing x. When you multiply x by a number, you are either squeezing, that means you're compressing, or stretching horizontally. X equals minus a half, and x equals 1, and x equals minus a half, the minimum point, and the maximum point is x equals a half, y is 4. The intercept is 2 still, doesn't change. The graph is now reflected along the y-axis because the maximum was here before. Now it's been here. So sketching the curve, this is a turning point here. And it will go all the way through to the maximum there. And then come down. You can see the point here compared to this one. You can see that the fx, that's the fx itself, and it's been reflected along the y-axis here. So if you go back here, it's been reflected along the y-axis, and the y value doesn't change, only the x value. This time it's half. And that's what you're seeing there, because you've multiplied by 2. If you divide by 2, it will double. If you multiply, whatever you do, it's going to be, the new coordinate will be x over a. Again, f of x, when we multiply out the factors, we got x cubed minus 3x plus 2. So now we replacing the x by minus 2x. So we get minus 2x cubed minus 3 into bracket minus 2x plus 2. And if we expand that out, we get minus 8x cubed plus 6x plus 2. Obviously, if you put x equals to 0 here, we will get the 2, so that's good. And if we put x equals to a half here, or 1, if you put x equals to 1, we should get 0 because that's 1. 6 plus 2 is 8. 1 here, that'll be minus 8, so that's y 0. So that works, everything works, so that's good. If you put x equals to a half here, you will get 4. So now the coordinates at this point here will be 1, x is 1, comma, y 0. And here is the coordinate here will be x is a half minus a half, 0. The coordinate here at the turning point will be x equals a half, 4, and here the turning point there will be 0, 2. And that's the equation of f of minus 2x.